class. And Boyce-Codd normal form is stronger than third normal form, where in third normal form, whenever there are functional dependencies, either the left-hand side is the key or the right-hand side is a prime attribute. For Boyce-Codd normal form is far stricter because it states that for all functional dependencies that you have in R, the left-hand side must be a key or a super key of R. So I'm going to do the decomposition algorithm, and it's actually very similar to the third. In fact, it is just like the third normal form algorithm. So I'm going to, instead of writing the algorithm, I'm going to just do an example and show you how to divide a table into Boyce-Codd normal form tables. So similar to third normal form, you should, the input is R, a table R with all the attributes and the set of FDs on R. And the output of the algorithm is a set of relations that are in Boyce-Codd normal form. And where you can get the original relation back by just joining these relations. So I'm going to use an example to demonstrate this algorithm. Like I said, in terms of the wording, it's exactly similar, the way it works, to the third normal form algorithm. So this is the example. We have a table, R, and I'm going to use the social security number, first name, and the school example that we were doing earlier. So office number, D number, school, student number, building, D name, and size. Okay, so I got a few more attributes than our previous examples. And we have the following functional dependencies. We have on this table, we have FT1, so given the social security number, it determines the first name, the office number, and department number. Then we have FT2, where we have school and D number together determine the student number or the building, the D name, and the size. Then FT3, the number of students will determine the size of the school. So student number determines size. And then we have FT4, which is office number determines the building. Okay, so we have these four functional dependencies. So the idea is that the question is R in Boyce-Codd normal form? So first we have to determine if R is in Boyce-Codd normal form. So the very first step in order to determine that is to find the key for R. So that's the first step, step one. So find key of R, and you use the closure of attributes property that we did in the previous classes. Okay, so so let's see. We have. I just want to bring this table down. Just okay. So this is the table, and we want to find the key for this table. So let's start with social security number and see is social security number, could that be a key? So we use closure. So from social security number, we can get the following attributes. Okay, is there anything else we can get from here? We can get building because we have this last one, office number determines building. So we can bring in building. Mm. I think that's it. We can't get anything else from social security number. So social security number is not a key. So just let's look at school and D number. We can, let's try. Yeah, I mean, it's not going to be a key anyway, but one of the things by just looking at this, because from school and D number is not going to, you're not going to get social security number by looking at school and D number. But anyway, I'll put it in there, school DNO plus is equal to DNO student numbers, building, D name, size. That's it. I don't think we can get anything else from here. So that's not a key either. So what do you think would be the key? Neither of these are the key. So there's no point looking at FT3 and FT4. You're not going to be able to generate. So can anyone jump in? What do you think would be the key?
SSN in school?
Yes, SSN in school would give you the key, because if you look, D number, SSN generates D number. So so you should be able to get it with, if you do SSN and school, you should be able to get all the attributes on the right-hand side. So I'm not going to write it down, but it'll give you all the attributes. So the key is SSN and school. Okay, so so now that we have the key, and if you can look and see, are there any other candidate? Can we get any other keys? Let's see. I don't think there's nothing else actually. You can look through it, but there's nothing else that's going to be a key. So we only have SSN and school number as a key. So then you go on to step 2, which is the repeat. So this step you're going to keep repeating until all the tables are in Boyce Codd normal form. So here we are going to pick any functional dependency that violates Boyce Codd normal form. And then you divide R into R1 and R2. So let's say the functional dependency we picked is, A going to B. So R1 and R2, R1 would be A and B, where A is thing, and R2 is going to be R minus B. Okay, so I'm not showing the explicit bringing down of A. So so let's start with any functional dependency in the original table that does not satisfy the rules. And there are many of out here. FD1 does not satisfy, FD2, FD3, FD4. So you can pick up any. So let's start with FD4. I mean, just randomly, I'm going to start up with that. So we have, so what I did is I picked up FD4. So I'm starting with, which is office number determines building. So we have R1 is so we have R1, and then R2 is going to be just the rest of the fields. So R2 will bring down office number, and then everything else other than building will come down. SSN, FName, school, DNO, size, DName, and student number, that's right. Okay. So we have R1 and R2, and the key for this is social security number and school together is the key. So these two are the key together. So R1, if you look at R1, R1 just has this one functional dependency, office determines building. So R1 is in Boyce Codd normal form. So then we look at R2, and R2 is obviously not in Boyce Codd normal form because there are functional dependencies in here. So we have, I think we have, okay, let me just lose the, okay, so we have student number determines size. That's one functional dependency that's there. Then we have social security number determines FName, office number, and DNO. Okay, so we have a minimum of 2 of these that are violating Boyce Codd normal form. The left-hand side is not the key. So let's just pick any one of them. So R2 is not in Boyce Codd normal form yet. So we have to further reduce R2. So you keep repeating step 2 till we bring everything down. So this is step 2 again. So let's pick up this functional dependency, the student number determining size. So we have a number of students determining the size of the school. So let's bring R3 to be student number and size, and then R4 is just the rest of the attributes. So we bring student number down, and then you bring everything else there, which is there. So we have SSN, office number, FName, school, DNO, DName. Okay. So now again, we have these two tables, R3 and R4, and we can look, R3 is in Boyce Codd normal form because student number determines size, but not R4. So let's pull out the social security number violation. So we have social security number determines student number. What is social? Just, oh, doesn't determine student. Social security number determines first name, office number, and department number. So we're going to pull that one out. So So R4 is not in Boyce Codd normal form. So we keep doing step 2 again. So we have R5, which is SSN. Where SSN is the key, and then you have R6, which is SSN, you bring it down, and then we have school, student numbers, and we have D name. Okay, so here SSN and school are the functional dependencies. So at this point, I think there's no other functional dependency in either R5 or R6. So we can check just to make sure. So we have, so there's nothing more. Student number determines size, office number goes to building. So yes, everything's out. So these two are in Boyce Codd normal form. So finally, we have the final table. So we have R. So we have R is equal to R1, join of R3, join of R5, join of R6, and R1, R3, R5, and R6 are in Boyce Codd normal form. So that would be the output of the algorithm, or one possible output. So any questions? Did you understand the working of this, how the algorithm went through?
Can you just quickly go over why R6 is in Boyce Codd?
Because the only functional dependency in R6 is this one: social security number and school determine student number and D name. There's no other functional dependency in R6, and SSN and school are the key. So so it satisfies Boyce Codd normal form. So the thing is, if you notice, I randomly picked up some functional dependency that wasn't being satisfied. So again, if you go down here, I started with I picked up F4, office number goes to building, and I said, you know what, that doesn't satisfy functional dependency in the original table R, because the key in R is SSN and school. So, and we have this functional dependency, office number. So I randomly picked out functional dependencies and I started. So that's another thing with Boyce Codd normal form, or even third normal form. The order in which you pick up functional dependencies will determine the final output. So you can get different kinds of outputs when you run the algorithm. So I want to give an alternative way of, so suppose I didn't do it in this order. Suppose I did it in another order. So you could have several valid Boyce Codd normal form decompositions. So it's not just a single one. So for this example, so I just need to bring it down again, because otherwise I have to keep going up and down. So it's not. So let me just bring this down, the functional dependencies, because I just don't want to keep going up and down. Okay, so this was the original table, and these were the functional dependencies, and we had found that the key was SSN and school. So instead of starting with FD4, let's start with this one, FD1 this time. So I'm going to start up with this functional dependency that's violating. So I'm going to have R1 now to be SSN, FName, no, office number, and D number. Okay, and then R2 is going to be SSN, office number, D number, school, student number, building, D name, and size. Okay, so and here SSN and school are the key, but here we have other attributes. We have student number determines size. We also have office number determines building. So that has gone out. So if you notice, office number goes to building is not there anymore because it's here and here. So let's look at this functional dependency, student number and size. That's one I'm going to take out. So we have right now that R1 is in voice code, but not R2. So we keep doing step 2. So we're going to have, we're going to have R3, which is going to be size, where student number is the key here, and then you have R4. Okay, so now we have, and if you look at table R4, there are no functional dependencies in here. Other than the key, the SSN school determines everything else. So therefore, S1, R3, and R4. So these three are in voice code normal form. So we have R is equal to R1, R3, join R4, and R1, R3, and R4 are in voice code normal form. So this is and maybe you could get more. I just did 2 of these. So really, depending on how in what order you pick up functional dependencies, you could get different tables. Also, sometimes, remember I mentioned that when you're given functional dependencies, it's a good idea to look at the functional dependencies and find out all the different possibilities that are possible before you start out. By what I mean is sometimes you have, you could get, so if you're given a functional dependencies where it's given that A goes to B and then you're given B goes to C. So now you know that A also goes to C. So you should try to derive all the functional dependencies that are implicit in there too, before you kind of start off on this, before you try to divide the original table into voice code. So it is rather tricky. I mean, the algorithm is not that, it could be rather tricky actually. So you need to be careful when doing it. I mean, I would say that, dividing a file, normalizing files is not exactly straightforward. It does require you to pay attention. So it does require, because there are some problems that you can kind of do on an automatic mode, but normalization is not exactly something that you can do in automatic mode. It does take some effort into doing it, at least for some problems. I mean, some problems are easy. So do you think you understood? Because I'm going to give a bunch of other examples now. Do you understand the example that I've done so far? Okay, so let's look at another. So this was example, so I did. So let's do the next example. Okay, so we have R. So I'm now going to just use A, B, C, D. It's just too painful to write down meaningful stuff in there. Plus, sometimes when you write meaningful stuff, then you get sidetracked by the logic, the meanings. So we're going to just use A, B, C, Ds from now on. Okay, so we have A, B, C, D, and then you have the following functional dependencies. You have AC goes to D, D goes to B, D goes to A, D goes to C. You could have just written that down as D goes to ABC, in short. Um, so, um, yeah, I just want to say that this is equivalent to saying D goes to C. You don't have to write them down as separate, but sometimes if it's given like that, just remember that's the same thing. So the first thing, of course, is to find out what are the keys for this particular example. So we have AC goes to D, and D goes to ABC. So AC is a key because if you do AC plus, you can get D and you can get B. So you can get everything. Is there another key for this besides AC? The trivial key. Okay, so D is a key just trivially because D determines ABC. But so you have two keys for this table. You have AC and you have D. They both are keys. So the question is R in Boyce-Codd normal form? So before you start dividing, you have to first look at it and see, is it in Boyce-Codd normal form? Because there are two functional dependencies. AC goes to D and D goes to ABC.
I'm gonna go with yes, it is.
Yeah, this one is, I started up with a simple example. It is already in Boyce-Codd, so you don't have to divide it because, AC gives BD and D goes to ABC. So they both are keys. So the left-hand side is a key in all these functional dependencies. So the table R so you don't have to divide this any further. So always look when you start up, just see whether you have to divide it or not. And if you don't have to divide it, don't. So that was, so now let's look at this next example. So we have the following functional dependencies. BC goes to A. So the first thing we have to find out is R in Boyce-Codd normal form. So before you can do that, first, can you find out the keys for this relation? There are multiple keys. So I would like you to find the keys for this table. So let's see. Again, when you do these, it's a good idea to see what should always be on the right-hand side. You have CD is just not derived in any of these on the right-hand side. A, B, and C are all there, but D, so every key that you have must have a D in here because D never appears on the right-hand side. So you always have, so let's just look at CD. Will that give you the key? Okay, C, D, C goes to B, and BC goes to A. So key is also CD. And let's look at AD. So you have A, D. Okay, so A goes to C, and AC goes to B. So key is AD. So all of these are keys. BD, CD, and AD are all keys for this particular table. So the question is the table in Boyce Codd normal form? So these are the keys. So is it in Boyce Codd normal form? Anyone? Is there any functional dependency that violates Boyce Codd normal form in R? Because that's really what the question, when you're asking is the table in Boyce Codd normal form, what I'm really asking is there at least one functional dependency that violates Boyce Codd normal form? So anyone, can you?
BC.
Which one?
The BC.
BC, oh, BC goes to A, yes, that violates. BC goes to A, also A goes to C, C goes to B. And by the way, when you say A goes to B, I just wanted to, we have A goes to C, C goes to B, that means A also goes to B. So there is that functional dependency. So A goes to C, C goes to B. So there's another functional dependency, A goes to B also in there. So I'm trying to see is there anything else that we are missing. So we also another one out here, by the way. So look out here. We have C goes to B. So we have C goes to B, and then you have BC goes to A. So this should imply that B C goes to, no, that should not imply B goes to A. No, I've got that wrong because it should be, it should be C goes to A. Yes, so that should imply that C goes to A, that's right. I was going to say B because you have C goes to B, C goes to B, and then BC goes to A. So that will imply that C goes to A. So there are two other functional dependencies that you could derive from here. I'm trying to see is there anything else out here. A. So C goes to A. So these are the functional dependency. That's why I said you got to be a bit careful because some of these are kind of tricky. So look at the functional dependencies and see if you can get them all. So these are the functional dependencies. So as you can see, we have so many functional dependencies out here that you can actually come up with many Boyce Codd normal form decompositions. So let me just pick up a few of them. So the first one, you can pick any of them. So let's pick up C goes to B. So we have R1. So, and then you have R2, which is A, C, and D. So we have R2, which is A, C, and D. And the key for R2 is either CD or it's AD. But you have all these other functional dependencies in there. So we have A, C goes to A in here. Right, C goes to A. Is there anything else out here? But at least you have one that you can pull out from here. So therefore, So this table, this one is in Boyce chord, but this is not in Boyce chord. So I have to further divide it. So we have 3, which is CA, and or AC, doesn't matter really, because C goes to A and A also goes to C. Because if you look out here, C goes to A and A goes to C. We have this one out here. So they both are keys really. So you have a table where they both are kind of, so both the key out here, you have either A is a key, so is C a key. You know, they both kind of determine each other. So you could bring R4 down to be any of them. So we have, could be either you can bring down A or you can bring down, it's really up which one, either one's fine. So let's say R4 or R4 dash. So you could bring any of these down. So you could have, so in this case, you have the following. We have, so R is equal to R1. I just want to say these are Boyce chord. These are all Boyce chord normal forms. So we can have join R3, join R4. You also have R is equal to R1, join R3, join R4 dash. They both are equivalent. Um, so that's, so we have already, from just picking up C going to B, we have 2 different Boyce chord normal form decompositions, and they're both valid. So do you understand this one? Okay, so just to see whether you understood, I mean, to test yourself, let's look at this. Instead of starting with C goes to B, let's pick, doesn't matter which one I pick. Okay, pick up this one, A goes to B. So let's start with the functional dependency. Goes to B. So can you do a division into Boyce chord normal form where you're starting with this one? So R1 will be, in this case, so let's call it, yeah, R1 is going to be A, B, with A going to B. So the key is A. So can you do the division for this one? And if you don't understand, just ask. I know this is online, so it's a lot more, it's kind of difficult to ask compared to a classroom, but go ahead and ask me, because the normalization is not given so well in the textbook. I put the PowerPoint slides, which are really just a copy of the textbook, but it's not explained so well. So if you don't understand, just ask me.
Are you asking for the R2 in this
Yes,
case?
R2, and then keep going beyond R2, because R2 will not be in Boyce chord normal form.
Okay, so it'd be A, C, D, right? For the second.
Yes. So R2 in this case will be A, C, D, where the key is CD or AD. But it's not in Boyce chord normal form, because you have this, the same thing. So the rest of it is going to be like the previous problem. So we have, so you can have R3 going to, either you can bring A or you can bring C down, it doesn't matter. So you can have AD, AC, and then R4 could be either AD or R4 could be CD. So I'll call it R4 dash again. So it's this reduced down the old one. So again, so if you start with A, B, so you can have R going to R1, join R3, join R4, or you could have R is equal to R1, join R3, join R4 dash. So both of them are fine. So really, I mean, we just for this small table, we've come up with 4 different kinds of way of dividing the table. Heavy, I'm trying to see A, B, C, B. Okay. Yeah. So, I mean, you can just play around with this and see if you could come up with others. I just came up with these. So if you don't have questions, I'm going to give another problem and I would like you to try this out. So this was example 4. So let's look at example 5. So we have A, B, C, D, E. And I'm writing E in uppercase because my lowercase e and A and C and all look very similar to each other. So we have okay, so these are the functional dependencies. So first is find the keys. And again, while you're doing this, I just want to mention that there is no assignment due today. It's going to be due next week. So the next quiz was going to be on normalization and everything that I've done, including stuff I'm doing today. So it's really going to be on normalization. And the next assignment will be on normalization too. So if I can get the assignment ready in time, I'll post it up there. So the assignment is a good study material for the quiz. This week's quiz and even for next week's quiz, because next week it also, I'm guessing, will be on normalization. But it also might be on MVDs. So anyway, the assignment, if I can get it ready in time, is a good study material for the quiz because the assignment is going to be all on normalization. So I'll post it, though the assignment, of course, is not going to be due next week because next week the PHP assignment is due. So the assignment will only be due the week after, but I'll post it. If I can get it ready, I'll post it tomorrow so that you can practice, you can do that for the quiz. It'll help you study for the quiz. So BED is a key. Is there any other key? There is actually one more. So did anyone find any other key? Or at least one more? I might have missed some because in these you have to be so careful.
BDA.
Okay. B, D, A. Okay, let's see. B, D, A. Okay. B goes to C. A and C goes to E. Yes, so that's also a key. So yes, so there are 2 keys, BED and BDA. So, so I'm going to write down, because it's 9:59, I'm going to write down a couple and you can check this out. Are these, because you might as well practice for the, so I'm going to give you two options and check and see, are these voice chord normal form decompositions of this. Okay, so check and see whether these are work. I mean, it's a good practice for the quiz. So I'll see you on Wednesday. It's 10 o'clock, unless you have more questions. I'll see you.